Imagine your old, rusty car, the one forgotten in your driveway, no longer useful. What if it didn't end up rotting in a landfill? Instead, it transforms into something massive and essential, part of gleaming railway tracks that carry high-speed trains across
Tons of worn-out cars. To most, they're junk. Here, they're treasure. Giant claws feed the beasts. Shredders that rip decades of driving into bite-sized steel. That scrap is melted down, poured brighter than the sun, and rolled again and again.
Every year, hundreds of millions of tons of scrap vehicles pile up worldwide. But instead of wasting away forever, this metal gets an incredible second life as super strong, durable steel for railway tracks that support mass.
It's the perfect example of a circular economy in action. Waste reborn as vital infrastructure that connects the world. Let's dive in, starting from the very beginning.
It all kicks off at massive scrapyards around the globe. Thousands of end-of-life vehicles, cars, trucks, vans arrive every day. Tow trucks unload them, stacking into enormous mountains of twisted metal.
First, skilled workers carefully inspect each vehicle and safely drain all hazardous fluids, oil, coolant, gasoline. Batteries and tires are removed separately for their own specialized recycling processes.
Now the cars line up and feed into giant hydraulic crushers. These monsters flatten entire vehicles like pancakes in seconds, compressing them for easier handling and transport. The satisfying crunch echoes through the...
These flattened car bodies slide onto long conveyor belts, moving steadily toward the heart of the recycling facility, the Mega Hammer Mill Shredder, a true beast of industrial destruction.
Powerful magnetic separators pull out all ferrous metal, while eddy current systems eject non-ferrous materials like aluminium and copper for separate processing.
The clean steel fragments, known as shred, pile up in huge stacks, ready for the next transformative stage. Trucks and conveyors haul them to massive steel mills. From here, the journey toward new life is...
At the mill, giant buckets load the shred directly into the electric arc furnace, a monstrous chamber where the real melting magic begins.
Massive currents, up to 100,000 amps, spark violently, heating everything in an instant explosion of energy.
Shred pours in from massive buckets above. In minutes, the steel begins to glow bright red hot. Temperatures climb rapidly past 1600 degrees Celsius. The entire charge...
Giant oxygen lances descend into the furnace, blasting pure oxygen deep into the molten bath. Impurities burn off instantly in spectacular bursts of flame and sparks, a controlled infinite.
A thick layer of frothy slag forms on the surface, trapping phosphorus, sulfur, and other unwanted elements. This slag will later be skimmed off, leaving cleaner steel beneath.
Operators constantly monitor the chemistry, taking samples from the glowing liquid. Precise adjustments ensure the steel meets exact railway specifications. Strong, tough, and flawless.
Critical alloying elements are added now. Manganese for toughness, vanadium for strength, chromium for corrosion resistance. These turn ordinary recycled steel into premium...
Massive ladle tilts slowly, pouring thousands of tons of glowing orange molten steel into a waiting secondary refining station. The river of liquid metal lights up the entire mill.
Here in the ladle furnace, final refining happens. Argon gas bubbles stir the melt, removing tiny inclusions and gases. The steel becomes ultra-pure, ready for its final...
The refined molten steel flows smoothly into the tundish, a reservoir that feeds the continuous casting machine below. Everything is timed perfectly for non-stop production.
Molten steel pours through the water, cooled molds, the outer skin freezing instantly, while the core stays liquid and alive inside. Long, fiery strands are born, glowing as they travel down the line.
The solidified strand continues its journey downward, guided by a series of powerful rollers. Oxyacetylene torches automatically cut the endless strand into massive red-hot blooms or billets, each weighing several.
These glowing billets are transferred immediately to walking beam reheating furnaces. Here, they're heated evenly to around 1200 degrees Celsius, preparing the steel for the intense shaping ahead.
Can't stand. Massive rollers seize it, squeezing with millions of pounds of force, drawing it out, thinning it dramatically. Steel flows like molten...
Pass after pass, the steel travels through successive stands. Each one squeezes it tighter, pulling it longer and thinner. The glowing bar races ever faster as it stretches, reaching lengths of more than 100 meters in just seconds.
Several universal rolling mills now take over. These precision stands form the classic I-shaped rail profile. A thick head for wheel contact, a thin web in the middle, and a wide foot for...
As the rail nears its final dimensions, edging rollers refine the head and foot contours perfectly. Computer-controlled systems ensure micron-level accuracy, critical for safe, smooth...
Finally, the hot rail emerges from the last stand at full length and perfect profile. It's transferred to long cooling beds, where it slowly cools in heat. Straightening machines now grip the cooled rail and use powerful hydraulic presses to correct any slight bends. Rollers rotate and align it to within millimeters.
Precision saws cut the rail to standard lengths, typically 25 meters or longer, continuous welded sections. Sparks fly as diamond blades slice through the hardened steel with incredible accuracy.
Your quality control begins immediately after cutting. Engineers measure every dimension with laser precision, checking head width, height, web thickness, and foot symmetry. Even the slightest deviation is...
Ultrasonic testing equipment rolls along the entire rail length, sending sound waves deep inside the steel. It detects any hidden internal cracks, voids, or inclusions, ensuring zero defects for safety.
Surface inspection follows. Automated cameras and grinders. They scan for any imperfections on the rail head or sides. Grinding wheels smooth out minor flaws, leaving a flawless mirror-like finish.
Now comes heat treatment. The railhead passes through induction heaters that rapidly raise its temperature again. Immediate quenching with air or water hardens only the running surface, creating extreme wear resistance while...
Perlitic steel structure forms in the hardened layer, a microstructure proven to last decades under heavy train traffic. This head-hardening process is what makes modern rails last so long.
Anti-corrosion coatings or protective paints are applied to the web and foot of the rail. Some premium rails receive special wax or polymer layers for extra protection in harsh environments.
Each rail leaves the mill with a story pressed into its side. Manufacturer code, production date, steel grade, and heat number. That line of characters ties every finished track back to the steel it was born from.
These gleaming new rails arrive at construction sites worldwide. Crews unload them carefully and align them end to end for the next crucial step, welding into continuous tracks.
And thermit welding, flash butt welding, two ways to fuse rail ends into one unbroken ribbon of steel. The molten metal fills the mold, sparks fly. A grinder.
Tracks are laid on prepared ballast beds of crushed stone, with concrete or wooden sleepers placed at precise intervals. Clips and fasteners secure each rail firmly in position.
Tamping machines pack ballast tightly under sleepers, leveling and aligning the entire track to perfection. Laser-guided systems ensure millimeter accuracy for high-speed safety.
Trains. High-speed bullet trains now thunder over these very rails. Steel that once powered your old family car, now carrying thousands of passengers at over 300 kilometers an hour.
Recycling scrap steel uses 75% less energy than mining new iron ore, saving enormous amounts of electricity and fuel every year. It's a brighter, cleaner way to build the world around it.
It also slashes CO2 emissions dramatically, preventing millions of tons of greenhouse gases that would have been released making virgin steel.
Landfills stay emptier, and natural resources are preserved. And old vehicles that once clogged cities now form the backbone of sustainable transportation networks.
Every single year, millions of end-of-life cars go through this exact transformation journey, from rusty scrap to critical infrastructure.
What begins in chaos and rust is cut, shaped, and aligned. Spark by spark, sleeper by sleeper, it becomes something greater. Perfect rails stretching across continents.
Trains glide silently and swiftly over steel, born from yesterday's traffic jams.
This is the hidden power of industrial recycling, turning waste into wonder, trash into triumph. What we throw away can come back as something extraordinary.
A true circular economy masterpiece that most people never even notice. Every bottle, every window, every shattered thing is reborn under your feet.
But every time you ride a train, remember, the steel beneath you might once have been someone's old car.
From forgotten driveway to high-speed highway of steel, this is how millions of old cars become the railway tracks of tomorrow.
An industrial process so satisfying, perfectly choreographed from start to finish. Every sheet, every cut, every motion, precise. Robotics and crafts
from scrapyard destruction to gleaming rail perfection. The cycle continues. Waste reborn, world connected.